Welcome everyone to the Simio Solutions series. Today, May 19th, we are going to cover Constraint Logic. My name is Dan Vasilini. I'm the Global Vice President of Sales here at Simio. Doing most of the talking today is going to be Ryan Luttrell. I'll let him introduce himself when I turn it over to him. Before we get started, a few housekeeping items. Just be aware, today's session is being recorded for replay purposes. So if you'd like to go back and watch this session in the future or suggest to a friend or a colleague, it will be available on simio.com very soon after the session ends today. Also, everyone is going to be entering on mute. So if you'd like to ask a question during today's presentation, on the right side of the screen, on my screen, you might have moved the box around, but there should be a GoToWebinar box somewhere there where there's a question area or a chat area. You can go into that question or chat area, type your question in. Those questions will go to a central location, and at some point during today's presentation, we'll try to get to all the questions. The session today is scheduled to last 60 minutes. We have intentionally left a few minutes at the end for Q&A. We did a dry run of this presentation earlier, so we might be butting up against the 60 minutes, but we will do our best to answer some questions today. Lastly, before I turn things over to Ryan, so from an upcoming solution schedule, we have two more currently on the calendar. Just for anyone that attended our first session last week or 2 weeks ago, excuse me, we did do it on a Friday. Obviously, we're doing today's session on a Thursday. We're going to do sessions going forward here on Thursdays. It seems like that might be a better day based on the survey we sent out. So we are going to do them on Thursdays here at 11 a.m. Eastern Standard Time in the U.S. We have the next two are scheduled June 2nd, June 16th. Our June 30th topic is currently being finalized. We do want to thank everyone that sent in recommendations for future topics. We did get a nice long list, and we are prioritizing those and figure out which ones we can cover in a 60-minute session. So we are going to have our finalized calendar, or at least an extended calendar, done here shortly. If you do have any suggestions, if you didn't watch 2 weeks ago's session and this is your first solution series you're attending, we are looking for topics. So feel free to send a message to me. It's dvasilini@simio.com, and you can see the address there at the bottom of the screen. Always send me any recommendations you have. And also following up on this session, you will probably be getting a questionnaire asking what you thought of the session, and also with some follow-up for any future suggestions. So with that being said, I will turn things over to Ryan. Ryan, you can go ahead and grab control of the screen and start from there.
Thanks, Dan. Switch.
And I'm going to turn my webcam off, just to eliminate some bandwidth issues.
All right.
As you're trying to get something ready, you want me to do a song and dance or anything?
Yeah.
All right.
Got it. All right. Okay. Hello, everyone. My name is Ryan. As Dan mentioned, I'm a solutions engineer for Simio. So that really means I'm a technical representative for the sales and marketing team, as well as I support many of you that I see in attendance through our Hypercare program. So welcome everyone. We're here. I'm here today to talk about constraint logic and different constraints within modeling. So my objective today with this presentation is really to answer these few questions for you at some capacity throughout the presentation, or even in the software demonstration in the back half of here. So first is, what are some common constraints that we experience in day-to-day life or in operations? How can I improve the performance, or how can I understand, the impact of different constraints that I'm experiencing? And then what is the best modeling method for different constraint types? So we're going to try to address all of these during this presentation today. So what are we going to talk about? We'll get a little philosophical at the beginning here and talk about, what are constraints. Then I'll introduce the constraint logic element within Simio. And then we'll hop over into the Simio software to talk about this restaurant example that I created. And then within the example model, we'll talk about different constraint types that I have modeled within that example. So again, to get a little philosophical here, what is a constraint? We talk about this word all the time, and from a day-to-day perspective, we may see it slightly different than maybe a mathematician might see a constraint in an optimization model. But how we see a constraint, and this is just a quick definition that I found online, is it's a limitation or a restriction but could really mean various different things, right? It's pretty broad, but at its core form, it is truly just a limitation of something that I'm when I'm trying to do something. And commonly we are trying to model to find the bottleneck. The bottleneck term is always a common term that we hear within the simulation space, and really the bottleneck is just a constraint that has the largest impact performance, or the largest performance impact into whatever system you're modeling. Some really common constraints, in your day-to-day life that you may be experiencing are, time, money, and space. Those pretty high-level constraints that I think we all experience, right? I know I'm pretty limited on how much time I have in a day. Would love to alleviate that constraint. But so just wanted to kind of set the stage here of a little bit of explanation of, what are we talking about when we say what is a constraint? So now let's talk about some common modeling constraints. When we start with a simulation project, we're typically using the simulation model to model various different constraints within the system, and then to understand their impact on performance, as I mentioned before. And some of the common modeling constraints that we come across are really, physical space. Maybe that's, your actual facility layout, and you have certain constraints on how much equipment can fit within the four walls, or you have certain restrictions on having so much space available for your vehicles or operators to work within the facility as well. Some of it maybe include like buffer sizes, so different buffer points that you have for holding, your work in progress along the way of the production throughout production. And maybe a constraint is, I probably maybe should have said a non-ergonomic workstation, but having the workstation itself set up ergonomically for the workers to use it efficiently, that could definitely be seen as a constraint in the system. Some other common constraints are really your resource capacity. So having the availability of skilled operators, also having available equipment to use it to do whatever operation is needed. And then also maybe there's a level of tooling or supporting equipment that's required as well for that same operation that would all need to be available and could be a constraint in the system if it is not available. And then there's this another common one is material availability. So do I have all the raw material in stock that I need to produce anything that I need the material for, as well as do I have the different inventory points in my production set up appropriately and the replenishment policies of those inventories set up. So maybe I find that because I am not replenishing a particular intermediate material quickly enough, or maybe have the wrong inventory policy there, I'm going to be constraining my production on having that item available. And again, we'll touch on some of these within the demonstration as well. Now, let's introduce this constraint logic element within Simio here. And this element is one of the newer features within Simio that allows users to more easily set up different constraints within their system. Within this element, there are 3 different constraint types that you can configure: a resource material availability, or a condition expression, which just allows you to set a custom expression that has to be that is evaluated and must be true before proceeding through the constraint. And there's 2 different process steps where you can apply these constraint types to, and that's a seize or a route step. Those could be applied directly to the process steps in process logic, or there are properties that are made available on the objects that have these steps built in that allow you to apply the constraint logic to it. Now, let's talk about this the restaurant example model that I have for demonstrating the constraints today. As many people know, I have a background in the restaurant industry, so it's very easy for me to describe the different constraint types that are in that industry, as well as I feel that industry provides some unique constraints that our traditional manufacturing environments may not experience. And let's talk about some of the common or the constraints that we're going to see in the model today first. So as the customer is flowing through the restaurant, there are different constraints that they're going to experience along the way. First, there has to be a lobby host available to check them in at the check-in station. And that in itself, the fact that the customer has to go to the lobby host is a constraint of the customer. They can't just go directly to the table that they want to sit at. I mean, obviously, that's something that that the restaurant has put in place to improve the service of the customer's experience. But it could be seen as an operational constraint. And then obviously, if the lobby host is off doing something else, that would be a constraint that they can't get checked in right away. Having an appropriately sized table is another constraint that they're going to experience, based on the group size that they come in at. There's only so many tables available that they could actually sit at. So having an available table to sit, and then also having an available waiter to service the table that they're going to sit at could be a constraint. As well as the utilization of that waiter could be a constraint. So even after they're sat down and they're potentially sitting there waiting for the waiter to take their order or deliver their food, if the waiter is overutilized, then that could be a constraint that the customer is experiencing. As well as in the kitchen side, if I order something and the ingredients that are required for producing that ordered item are not available, then there's going to be constraint time experience for getting that item produced. I'm going to have to first produce the ingredients and then assemble the item for the customer. As well as just the kitchen staff utilization. If they are overwhelmed, then it's going to take longer for them to assemble and produce my food. So with that, I'm now going to hop over into the software, and we'll look at this example model, as I mentioned, that I developed for the restaurant here. And just a high-level explanation of the model. We have customers that are arriving, and as they arrive, I mentioned this in the presentation, but we're assigning a group size here. And then based on their group size, they are routed to an appropriate table size. And I'll zoom in here a little bit on my model, and I can go into 3D mode just to show the different table sites that we have available. So this is the lobby host, or the lobby host check-in as the check-in station for the customer. So they go there first. Then they'll wait here in the waiting area if there's not a table available. And then they will be routed by the lobby host or transported by the lobby host to an appropriate size table. So we have some 6-seat tables up here up top. There's some 2 seats and then 4 seats in the middle. And then these are some larger tables, some 8 seats over to the left. And then so and I'll go ahead and start playing this here too. So once the customer is seated, a waiter is assigned to that customer, and then there's different activities that a series of task sequence that is required for the customer to go through at the table, right? So they will, place their drink order, then the waiter has to go make their drinks, and then they'll deliver the drinks back to the group of the customers and take their food order, and then, eventually the kitchen's going to be producing their food. Actually, I'll go over and show kind of this check-in view here, the customers being seated. Again, we can see the group size here of the customers. So we had a group of 4 seated at this foretop, and a group of 3 seated at this foretop as well. And if I just go back to the lobby check-in, after the customer after we receive their order, then the kitchen is going to be expected to produce the order, right? So we'll go into this kitchen view here. I don't think we've had any orders submitted just yet. It looks like we got one coming in right now, where you'll see these little white trays up top that represent the customer orders, and then they're going to get batched with these little food items that represent the 3 types of a small menu in this restaurant, but there's 3 types of items that they could order. And then each of the items require a different ingredient, and that's what's being produced over here is the ingredients to actually assemble the items here at the assembly station. So with that, that's the kind of the high level overview of the restaurant here. Now I'm going to talk about explicitly how I set up all the different constraints that I mentioned in these slides. So we'll really go through each of them. And the first one again was the lobby host requirement. So obviously, through the customer's routing, they're going directly to this lobby host station. It's represented as a server. So that in itself, the fact that they have to route to that lobby host, again, that station is a constraint. They have to go through that operation step. As well, on the server for the host station, I have put this constraint logic at C's constraint logic, and I'm going to go show that constraint logic element here before I show how we apply it. But If I click into my definitions tab, I can see there's a section here that now says constraint logic elements. And these are the 3 different elements that I have created for this demonstration. So let's look at the lobby host available constraint. I'll go ahead and open this up here. And so this one is a constraint type of the resource availability. And it says that I need a specific resource available, and that resource is the lobby host. So as I mentioned in the slide, like if the lobby host is off doing something else, I need to ensure that the lobby host is available before I can start my check-in process. So technically what this means from a Simio perspective is the customers are not allowed to enter the processing station of the host server until the lobby host, which is a worker object, is available and ready to check that customer in. The lobby host is responsible for transporting the customers to their tables. So if they're off doing that, they wouldn't be able to check the customer in. So that's the first constraint. The second constraint is the available table size. So I'll show that one here, and I'm actually going to make my nodes visible again and show a little bit of how I'm doing this. So I set up a custom routing group to route to the tables, and I'll go to the routing group here. If you haven't used the routing group, it works very similar to select from list. You provide a list, but it also gives you some different add-on process triggers, which I have utilized as well. And so with this, I'm actually using a table to define the list of tables that the customers could choose from. So I have a table routing table, not confusing at all. And if I come over to that table, let me just show you what this looks like. This has all the possible destinations of tables. And then there is this group size limit attribute that says this is the largest group size that could be sat at this table. And so that is a constraint, right? I'm not using the constraint logic element, but it is a method for modeling the fact that I require a particular size table or only a certain size of group can sit at that table. And just to show how I've set that up specifically, there is a selection condition that says my group size must be, the group size limit of the table must be greater than or equal to the group size of the customer group that's coming through, or the model entity. So so that's how the customers are selecting an appropriate table. And then after they select a table that they are going to be routed to, or I should say after they get routed to a table, then a waiter is assigned to that table and that customer. And I have a staff table that is creating all of the waiters, and we're keeping track of the statistics of what they're being assigned to do. So we're saying what is the total active table count that you're experiencing, or that you're currently responsible for, and then what is the total customer count? This customer count is going to come into play later on, so I'll save explaining that. But as I service 2 tables, I'm summing all of the customers that I'm servicing per waiter here. Now, so there's no limit right now on how many tables the waiter can be responsible for. So it's just going to find a waiter with the least amount of active tables and assign a table to them in that way. Okay, so then after the waiter is assigned, then again, the availability or the utilization of that waiter is going to come into play as well. And I'll showcase more of that in like a Gantt view here. So let me fast forward through the run here and show in the Gantt, go to this Gantt here. Let me find a great table example. Yeah.
As you're searching for that, let me just chime in here real quick. We've had a bunch of people join us since the initial introductions. During the presentation today, if anyone has questions in the GoToWebinar box, there is a place you can type a question in. Feel free to type questions in there. We are getting questions popping up, but I just want to make sure anyone that joined a little bit late knows how to express themselves. Thanks.
Yeah, thanks, Deb. So within the Gantt here, we can see for waiter 1 specifically, where were all the times that a customer was waiting on waiter 1 specifically, and that's what's shown in this constrained entities section here. And for a lot of times, it's a pretty small amount of time that it's waiting. It's probably mostly the time for the waiter to walk over to the table. But then there are some conflicts here where, you know, 7 is really trying to get waiter, but the waiter 1, but waiter 1 is working on customer group 1 right now. So they wait for a good amount of time there, about 4 minutes for that waiter to get to whatever action that they're requesting. And so that's just, again, an example of the waiter availability or waiter utilization constraint. Then the next one was having the item available. So as I place my order, then and I'll show this too really quickly. I have a set of task sequences that are set up for each table, and this is all the activity that, you know, the customer again is going through when they are sat at a table. And one of the activities here is prepare food, where I've used a process to create the food order and send it to the kitchen. And then that process is sitting there waiting for the food order to ultimately be destroyed. And then it would proceed down to asking for the waiter to pick up the food and then deliver the food to the customer. So the food orders technically never leave the kitchen, they get destroyed, but there's this, and we're modeling it in a way where the waiter is seized to go pick up the food and then seized to deliver the food. Or I'm sorry, I clicked on the wrong rows there, but you get the point. And then there's some eating time here that there's no operator, you know, required, or no waiter required for that action. It's just the customer is eating, right? So then after that, of course, then we collect payment from the customer, and then there's some remaining time where the customer may finish what they're doing at the table before leaving here. So if I go into the kitchen now, I'm going to see how we applied this item availability constraint. So let me stop the model here so we can get into the properties. And my server. So I placed this, there's another C's constraint logic that's applied to my item assembly server. And this one is called, you know, item available constraint. And let me go into the definitions and show you what that looks like here. So this constraint is of the material availability constraint. And this just says that based on the material that you selected to be ordered, and there's a process to actually select from this material table which item they're going to order, that material of a quantity 1, we're just doing only quantities of 1 in this model to keep it simple, must be available before I can actually enter the processing of that server. And then, you know, that allows me to also measure how much time each item is waiting on the specific ingredient that they're looking to consume. So that is done here, and then again, like there's a production station right next to it that is actually producing the ingredients. So as soon as we have a production come from that station, then that constraint would be alleviated, and the items would be able to enter the processing station here at the item assembly. And I'll showcase more on the results side the impact of that, but that's how that is set up there. And then the last one again was the kitchen utilization of having a constraint on the customer. So again, I'll show some results to showcase that here. Actually, let me set this up real quick. Sorry about this. Reset. Oh, it was actually meant to do that before, so sorry about that.
Ryan?
Yeah.
A question just popped in. It might be a good time to answer right now. So the question was, to optimize seating, how would you keep a group of 3 from using a 6-person table? Question mark. Could you allow that to happen under only certain conditions? Question mark. And they've been waiting for a while. You know, the group of 3. Could you let them go as an example?
Yeah, that's a great question. And if we had more time at the end, I was actually going to fill our time with showing how you would do something like that. So, you know, one way is you could put in another rule within your routing table to say that there is a minimum group size that is appropriate to sit at that table size. So obviously you don't want to sit like a 1 or 2 sized group inside an 8-seater. So you could say maybe a group of 4 is the minimum that could actually sit at that table. As well as you could potentially put a condition on the selection expression to say if the the entity has been waiting in the queue for X amount of minutes, that you ignore the selection condition of the minimum requirement, and then, or maybe even the maximum, because like in restaurants they'll pull tables up to another chair, or pull chairs from another table up to the table to try to make it work. Maybe that's how you want to put a policy in place to do that as well. So there'd be different ways that, and I was gonna, if we have time, I'll showcase how to do the minimum group size here. But hope that answers that.
No, that's great. Thank you. And I knew you were going to try to do it at the end, but I also know that time might be limited, so I wanted to get it out there.
It will be, yeah. Okay, so real quick, I just want to show some of the kitchen availability constraints here. So if I go into my kitchen staff, I'll see like this kitchen expo person is responsible for all of the item assembly and for packing all of the orders. So if I look at this, there are definitely items or times where particular items are constrained on the availability of that resource. So again, like I can start to then now I want to understand what has the biggest impact on my customer's performance, right? So we've talked about a lot of different constraint types, and all of them are being measured and from a Simio perspective. And now how do we display those results and understand which have the biggest impact on the customer's experience here in the restaurant? So now I'm going to flip over into the results tab and look at this dashboard that I created for looking at the different constraints that the customers are experiencing. So if we look at this, this is what we call kind of like a constraint Pareto, but these are all the different constraint types and items that the customers are experiencing constraint during their time in the restaurant. And so if I look at the top two here, the first one is table availability, right? So basically there's not a table for me to be sat at. And then the next one is this item assembly station, where it's within the kitchen that like items are being constrained by not having enough kitchen staff. And so the table destination one could be explainable by having not having enough waiters. Because again, like your turn time for the tables is higher, so therefore customers are having a hard time finding a place to sit. If I'm able to service my customers faster, then I will have more availability for the tables. So now let's set up an experiment, or look at an experiment that I set up for experimenting with these different staffing changes. So I want to add a waiter to see if I can get customers through the system faster and alleviate this table destination constraint, as well as I want to add members into the kitchen to see if I can alleviate this item assembly constraint that I'm experiencing here. So I'm going to go over to the experiments, and I have set up a model property to turn on a sixth waiter. So the baseline run was just with 5. And so this toggle here just turns that sixth waiter on and off. And then I have another scenario here where it's just changing the capacity of how many people I have inside the kitchen and that item assembly area. And so I'm doing a scenario where I'm just adding the additional waiter, adding an additional item assembly person, and then adding both. And obviously we see a pretty big impact to the time and system the customer is experiencing. And then we also see, like from a combo perspective, a reduction in the time to wait for a table. And so let me now say that this is the scenario that I want to run with. I like adding both of them. It gets these statistics to where I'm in a better place, to what I'm hoping to see. So I'm going to copy these scenarios controls over to the model, and let's run this again now. And look at the constraints now that we have these. Now that we have these new staff available, let's run it and see what our new constraint Pareto looks like here. So again, we ran through another day, and I've come back to my constraint Pareto, and now I see actually the waiter is the biggest one, but if we were looking at kind of like the sum hours, this is dramatically lower than what we saw before. I should have mentioned that as well, but yeah, so the total time here of 11 hours is a lot less than what the table destination was before. And now we see the table destination one all the way down here. And we see, again, the biggest constraint is the utilization of my waiters right now. So I may now experiment with adding more waiters. But let's say that's unfeasible. Say I can only afford to have 6 waiters, or there's only enough space really for 6 waiters to work within the space. Let's see what the next biggest constraints are, aside from anything to do with the waiters. And if I look down just past the table destination one here, I see there's an availability of beef, which is one of the materials that I have in the model here. So let me go down to my material availability constraint type and see the impact of the 3. These are the 3 ingredients that I have and how much constraints being experienced based on having those items available. So maybe now I want to experiment with having different inventory control policies for these ingredients to reduce this availability constraint. So let me go and I set up basically, again, a model properties to control all of the reorder points and reorder quantities of all of the 3 items I have here. And I then set up a OpQuest experiment to change those reorder points and reorder quantities for me and minimizing the customer's time and system here. So if I look at these numbers, from a expectation perspective, like these all seem feasible. It's all what I would expect these numbers to result at. So I'm actually going to then just now copy these over to my model, and we can see what the run here is. Go back, and now I have all my new inventory control parameters in there. But I did now lose the staffing changes, so let me go ahead and reintroduce those, and we could see what our new baseline is going to be after all these improvements have been made. Sorry, fast forward here. Results. Let's see all the constraints. And we still see some of the waiter availability and stuff, but now actually some of the biggest constraints is now on the resource availability at the item assembly station. So we have shifted the constraint to be on from being on the ingredient level to now being at the item assembly level. I have more ingredients ready to produce, but I still don't have enough people there to take the ingredients and assemble the items. So, I went through this effort to show, finding the bottleneck and resolving the bottleneck is a constant effort. You're constantly trying to determine what is that biggest constraint, and it's a moving target. As soon as you alleviate the first bottleneck, then the next biggest constraint then becomes your bottleneck, right? And you have to determine ways for alleviating that. So now that again, like high level explanation of the results that are possible there with the constraints. Now let's say that I want to look at the just average task duration of everything that's going on for my customers. So this is how long it takes to do every single task while they're at the table, and actually every task that's in the model. And I would look at, this is what I would hope to see. The biggest amount of time is them eating, right, and not actually waiting or having us interact with them as some of their biggest time. But when I looked at this before I made all those changes, actually the prepare food task, this one right here, what was causing some of the most delay or the most time required for a customer. So again, we would want to reduce that. And say like from this perspective, we still looked at our constraints, and my waiters here are still the most constrained item, right? Like their workload is too heavy, and it's affecting the customer experience. So I introduced this concept here called like a waiter customer limit, and I wanted to show how I would model something like that. So again, I are tracking the active customers per waiter in the staff table. And then I set up a constraint logic, and this is applied at routing to go to the table to say that my particular staff member, make this a little bit bigger here for us to see. Actually, let me open this up so we can see it here. My particular staff member here, active customer count plus my group size has to be less than or equal to this property that this model level property that I've created to define the waiter customer limit. So let me show that here. If I go and I'll look at the property. Right now I had set it to infinity. And then as well, we'll look at the node here that's doing the routing. If I click them, this is what how you would apply the routing level constraints. So far, the two that we looked at were C's applications. So this is a route application. And again, it says this customer is going to continue to wait in the lobby until the waiter that was assigned to them can take on more work, essentially, or take on more customers. So we've just applied that waiter limit constraint or a customer limit constraint to the routing decision here. And so now if I start to experiment with this, right? So I'm gonna have different numbers in place of a limit and see what kind of impact that would have. So I took our original baseline here, and then I took all of the different improvements that we had made so far in staffing and in inventory, and created two scenarios to just showcase what we have been able to improve so far. And then if I start to layer in a customer limit, we'll start to see what type of impact that would have on the customer statistics. So the time and system isn't affected too greatly, but certainly the time to wait for your table increases as we increase that customer limit. And that's expected, right? So if we're constraining how long or how a customer is getting to the table, then we would expect that time to increase. But on the positive side, we see a decrease in the time for waiting for the waiter to come greet the table, which was a measure a statistic I was using to measure the utilization of my waiters and how quickly they could respond to new tables being assigned to them. And so we see a reduction in that time, which is positive, and we also see a reduction in the total time waiting for food. So by doing this, we have reduced the workload on our waiters and reduced the workload on our kitchen to then ultimately deliver a better customer experience. And just to look at this in the response results, I'm going to pull up the response results here to look at the Simio S'more plot. Just to give a high-level explanation of this graphic here, this is a graphical representation of all the summary statistics that are captured from the scenario. So each scenario runs multiple replications, and from this view here, we can see the average of the 100 replications that I ran here. But this response results gives us a more graphical representation of the summary statistics, like this bar shows the total range. We see the mean represented with this gold dot, and then a confidence interval around that mean with the gold box. We see the 25th, 50th, and 75th percentile, and then the confidence intervals around those as well in the blue. I could take it even further, and I could show the histogram of the actual results that we're looking at here. I could even see a tick mark for all the individual observations that were collected. So just some additional visualizations that it provided. But if I look at and I just to get down to the two that I wanted to compare, I selected the improvement proposal plus this 10 customer limit per waiter. And I just wanted to compare what this looks like, because the 10 customer limit was the best performing from a limit perspective or customer limit perspective. And from an average perspective, they're very similar. They're producing the same average customer time and system. But again, on the other statistics, that we're seeing an improvement in the time that they're waiting. But then also they're experiencing a longer wait time to get assigned to a table. But from a customer time and system perspective, I see this as an improvement still in the reduction in the range that we're seeing here. So we are being more consistent about how we're servicing our customers, because not even our confidence interval around the mean, also our total range of the expected results is tighter than this new baseline up here. So we may even want to implement that just from a consistency perspective, so we can be more consistent for delivering service to our customers. Great. So that was the big things that I wanted to talk about here today. I'm going to stop for questions, and I can come back at any point to talk about that minimum group limit or any other things that come up in questions if we want to with the remaining time we have here.
Good. So thank you, Ryan. This will give you a chance to take a breath, and I'll read a couple questions off to you. We had a bunch come in. We'll see what we can get to, and then, like you said, if we want to get back into something else, we can. So I'm going to start off with questions. in the order they came in. So these might relate back a little bit beyond when you first, or back when you first started. So in terms of Simio logic, what is the difference between setting the worker as a constraint instead of a secondary resource?
Yeah, that's a great question. So the secondary setting it as a secondary resource states that that resource that worker must be there for processing. So it's a saying that you must see that's actually setting up the seize itself to seize the worker, and then you would see the utilization of the worker, in the results. From the constraint perspective, we're saying that before I seize potentially the workstation that the entity has arrived at, I'm going to check first that I have an appropriate worker to do the task that I need. And you may have multiple entities arriving to a server that require different workers of different types. And so before that entity gets, slotted into the processing station at that server, you want to ensure that you have the right secondary resource available to do that. So they kind of work together, really.
Okay, perfect. And as we're addressing these questions, just put this out there. If you are the questionee or the questioner, and we don't answer your question in its entirety, please feel free to reach out to us. Or if you have follow-up to it, also reach out to us. Next question, are there other options than the constraint logic element to model system constraints?
Certainly, yeah, and I tried to touch on that a little bit around having the group size limit at the tables. But really, there's several different methods for modeling constraints. The constraint logic element is just one element that we've added to make it a bit easier for those very specific constraint types. But again, like you get into situations where you may need to use the selection condition as a constraint, as I demonstrated with the table selection. From a model level constraint, you may have a limit on how many resources can be active at a time, or how much WIP you want to have inside the facility active at any point. And those could be modeled using several different methods. You could use the condition expression that I mentioned of making sure you're under the WIP limit that maybe you're setting as a model property. You could also use like a kind of like a dummy WIP resource that I've used in a lot of examples where I have to seize this WIP resource before I can proceed into the actual process, or maybe even a sub-process of the ultimate process. But yeah, if there were specific system constraints that you had questions on, I'd love to hear from you, and we could talk through the recommendation on how to model those.
All right, perfect. All right, next one that I always asking Ryan his advice. Okay, so do you have any advice on how to decide when to model a system constraint and when to ignore it?
Yeah, I think that the biggest thing is the level of fidelity that you're trying to model at. If you feel that the constraint will have a large impact on your performance, then certainly you're going to want to have it included in your model. There are probably some constraints that are so minuscule that you don't even need to include them in the model as well. Or some constraints that are hard to represent with either data or modeling logic that would be hard for them to represent it within the model. But I mean, I think of things like weather, right? That may be hard to, if this whatever your activity is constrained by weather, may be hard to define when that weather event is happening, or maybe it doesn't have as large of an impact on the ultimate performance where you don't need to consider it. That's a bit subjective, and it's situation to situation of when you would need to model that constraint. But again, like when we talk about all the different constraint types, even having your entities flow from station to station, the requirement to go to those stations is a constraint in itself. So by building a model, you're building out all the constraints or all the requirements for the system. So then it's really then how much of reality do you represent in the model, and that goes into how much detail do you need the model to be producing from a results perspective.
All right, next one. Someone saw that you were using a foreign key for object process type in your task sequence table. Could you go through that relational mechanic is how that could you go through that relational mechanic is being utilized in the model?
Yeah, definitely, definitely. That's a great question, a good observation there. So within table relationships in general, I will assume that there is some base knowledge of how we do table relationships in Simio, but if not, I'll just give like the high level overview here. So I have, I'm trying to create a relationship between the different servers that I have and this processing task table. So there are several servers that I want to follow the same processing task, or there's certain servers that I want to follow a different set of processing tasks. So what I've done is I've created this this table called object process types, which is just a string property, and then I set that string property as a column key. So now I can use this table to create relationships or within my other tables. So on my objects table that is creating all the objects that you saw here in the facility view, like all the different table types and all the different nodes that are required for representing the waiter operations, as well as any objects for the customer flow, right? So I have a source and a sink for the customers to enter and leave. And then on this table, I've used a foreign key to say which process type should this object use. And then I've used another foreign key in my processing task to denote which actual tasks are related to that process type. So for example, this is all the activity that's expected of the tables. When I use a foreign key here on the objects table, then that is going to set the reference to this parent table or this column key here. And so if I go into tables, I can see, okay, here's all the objects that are using my table process type. And then because I have a relationship to this object process type now, when I go to look at the processing task, I'm only going to see the processing tasks that are related to my process type. And again, that was just so that I could use the same set of tasks here for every table, essentially. I could have taken the approach where this was my column key, and then I used a foreign key, this is typically what I will do in models too. That this was just a bit of a special case, but I would set this as my column key, and then in my processing task table, my foreign key would be related to the object name itself, so that each object here in this table, I could specify which specific process sequence I want them to follow, or task sequence I want them to follow.
All right.
Great question, though.
Yes, yes. Have one or two more here, and then we are almost done. Can we add a constraint on flow regulator expressions? For example, at any given time, the total liquid pump rate should be less than a certain amount.
That's a good question. I have not looked too much into what is available from the constraint logic element. I don't think from a constraint logic element there's anything that interacts with the flow library. I'll have to confirm that one, but that would probably be more using process logic and different state attributes to regulate that flow. So yeah, I don't think that the constraint logic element itself interacts with the flow library. So it would be more utilizing other attributes of those objects and model states and process logic to help regulate that flow.
Okay. All right. All right. That's all the questions right now from a generic or from a general or a specific perspective right now. A few generic questions. Let me address them. So multiple people have asked if we're going to be able to share the model, and I'm going to answer that question. Yes. So we are going to share the model. Similarly to the way that we shared the model from last session, there will be on the Simio webpage. Once this recording is done here today, we will put the recording up, and then we will put a hyperlink along with that recording on that page that you'll be able to grab the model from. So it will be there. The next question was if we'll be able to share Ryan's presentation. So yeah, Ryan's presentation at the beginning, we will share that. We probably won't post that on our webpage, but if you do want that presentation that Ryan showed today at the beginning, as far as what constraints are all about, feel free to reach out to one of us and let us know. Let me check to make sure. So we have about 10 minutes left, Ryan. Do you want to cover anything else?
I mean, if we have the time, I could go through the applying the minimum group size and just showing that impact.
Yeah, let's go into that since the question was asked.
Yeah, certainly. Okay, so again, we would now say we want to introduce a new policy to how we're routing to the tables, where we only apply on my routing table a minimum limit. So I'm going to add an integer property here to say that this is the minimum group size that is appropriate for this table. And I'm going to keep it 0 for most of them, because I really don't want to apply a constraint other than to some of these bigger tables, where let's say maybe for a 6 seat table, I want the minimum group size to be at least 2. And then maybe for the 8-seaters, it must be at least 4, as an example. But for my smaller tables, I don't want to have a minimum limit. I think that the minimum of 0 makes more sense. So now, this is defined again per table of the minimum group size that is expected to select one of those tables. And if I go back to my node, now I'm just going to alter that selection expression to then consider the minimum size as well as the maximum size, or the size limit. So I'm going to open up my expression editor here, and I'm going to put an and statement to say that my table, table routings, the min group size, so that must be less than or equal to my model entity dot group size, right? And so now both of these expressions must result true in order for me to actually select one of those tables from the list. So this would be, a very easy way to implement that. And as we described kind of previously, this could get more complicated if needed, where maybe you ignore this minimum limit if the entity has been waiting in this queue for so long. So we could even wrap like a math if statement around that segment of this condition to say, if the model entity, I don't have anything set up to do this today, so imagine with me a little bit. And actually, I'll just add the state onto the entity just so we could do this. So we'll say like maybe my time. Oh, actually, I do have a time for the waiting table to start. So maybe I use that and say that minus time now. Let's do this here. Oops, sorry about that. So if my model entity waiting for table start time, let's do it. Time now minus that. If for some reason that is greater than, we'll say like this is presented in hours. So if for some reason that's greater than 20 minutes, then I want to basically just put this as a true statement. So so I need that to be, if that is greater than this, then this would result in true. If not, then we will require that this be checked as well. So that would be one way to implement that. Again, if I'm waiting for more than 20 minutes and I don't want to consider that minimum size, I will take a bigger table because I've just been waiting that long. So I guess any questions on how you would implement that? Or any other questions that have come in, Dana?
No, I think questions that have come in, for the most part, we've addressed all of them.
Great.
Let me check the question box one more time. No, I think we're good, and I think we are right at 55 minutes. So we will go ahead and start to wrap up here. I'm going to give everyone another 30 seconds here to type a question if anyone has anything. We still have a pretty large audience, so if you do have a question, feel free to type it in. Like I said, we'll give it another 15 or 20 seconds here. If you don't have the chance to type your question in, you can always reach out to us individually. Ryan, I'm going to steal control back one last time here, just to go through our upcoming calendar, and it's showing the wrong screen, of course. All right, perfect. I'm showing the right screen now, right? There we go, perfect. All right, so as I mentioned at the beginning, next two Thursdays from now, data-driven, data-generated modeling, very hot topic usually here within Simio. So I would expect to see a lot of people on the session 2 weeks from now. and then periodic statistics 2 weeks from then. And then, as I mentioned at the beginning of our session today, we will start to publish fill our calendar out here over the course of June, July, August, because of all the insight we've gotten and suggestions we've gotten from the audience from last week. Once again, from the audience from this week, if you weren't here last time, if you guys or folks have any suggestions for us, please email them to me at dvasalini@simio.com. You can see the email address there, and or you will be getting a survey follow up to this that you can fill out as well. Lastly, just to address the questions that have come in a couple more times as far as the model being shared, yes, we will share the model from this session. We will put it on simio.com. There will be a link to download it right on the Simio series page. So you'll have the ability to get this week's model. And then if you did not attend last week's session, I highly recommend going back and watching it. It's on dashboard reporting. There was a very large crowd for that, and a lot of people went and watched the recording already. That's on our page to watch from last week, and the model from that session is also out there. So with that being said, let me check the question box one last time. It doesn't look like we have any additional questions. Let's just say thank you to everyone for attending today. We appreciate the live attendance. It's always best when people attend live because we get live real questions. Obviously, we have no problem with you watching recorded as well, but the more people we get live, the more questions we get and the variety of questions we get. So thank you again for attending. Ryan, thanks for your prep for this, and we will see everyone in 2 weeks. Thanks again, and goodbye.